All right, so in this video, we're going to talk about analyzing rational functions. We'll spend at least 2 to 3 days on this topic. And today we're actually not going to do any graphing. We're just going to analyze. Okay, so over here in your notes that I printed out, I've gone over the directions on how to find vertical, finding horizontal. I'm not going to read it to you right now and write it again. It's already written there. I will apply those notes. Okay, so let's take a look at this first unofficial example. We're asked to state the domain, find intercepts, plot points, and state any asymptotes, and then sketch. Okay, so the domain, as you know, is found by setting the denominator not equal to 0, right, and solving for x. Okay, so obviously x can't equal to 0, right, because you'd be dividing by 0. Okay, so that's not necessarily new information for you. But let's find the zeros, or the x-intercepts. So the x-intercepts of this rational function is found by setting f of x equal to 0, and then solving for x, right? In other words, the zeros, the roots, the solutions. And notice when you cross multiply over here, right, 0 times x just equals 0. So in the future, when you're solving for the x-intercepts, you could just simply set the numerator of your rational function equal to 0. Now notice 0 equals 1. You don't have any x, right? So this is clearly a false statement. That implies in your graph that there is no x-intercepts. Okay, so anytime you get a false statement, that means there's none. All right, y-intercept is found by plugging x is 0. Right, where does the graph hit the y-axis? So f of 0 equals 1 over 0. Again, right, this is not a false statement, right? This is just undefined, which also means graphically that this graph is not going to touch the y-axis either. Okay, so no x or y-intercepts. And then the last thing we're going to do is plot some points. And so I'm just going to make a table over here. So if I plug in 1, I'm going to get 1. If I plug in a fraction like 1/4, well, 1 over 1/4, I'm going to get 4. If I plug in -1, I'll get -1. And if I plug in -1/4, I'm going to get -4. Okay, so at this point, we know this graph is not going to touch the x or the y-axis. And I'm going to do a little plotting here. Okay, so if you plug in 1, 1's right here, and then 1/4, 4 all the way over here, -1, -1's right here, and then -1/4, -4, 1, 2, 3, 4, all the way down here. Okay, so at this point, right, no pun intended, it's like, how do I connect it, right? Do I connect the dots? Do I, draw some kind of random trapezoid or parallelogram? And this is where the asymptotes come in, okay? So in your notes, I wrote, if you remember actually from last year, right, the way you find the vertical asymptote is you set the denominator equal to 0 and you solve for x, okay? So that's pretty straightforward. We set the denominator equal to 0, so x is equal to 0. It's just basically the y-axis. And then the HA is a little bit more involved, okay? And the way you figure out the HA is you have to compare the degree of the numerator and the denominator, okay? So what? So the degree right here of my denominator, right, is simply just 1, okay? That's x to the 1. Now over here, right, in my constant here in my numerator, I can write x to the 0. So the degree in the numerator is just 0. So in the notes, I wrote this down, right? If the degree of the numerator, which is 0, is less than the degree of the denominator, which is 1, right? Therefore, you can say that y is equal to 0 is your HA. Okay, so a little bit of memorization here. I'm going to graph y is equal to 0. X is equal to 0, right? You can't see the dashed line. Okay, now, asymptotes are something that the graph approaches but never ever crosses. Now, vertical asymptotes are absolute, meaning you can never ever cross a vertical. But later on in this section, you will see that the graph can cross a horizontal, but can never ever cross a vertical. Okay, so there's your sketch of the graph y equals 1 over x. And let's move on to our next unofficial example. If you take a look at the next problem where it says, use limit notation, to graph, or not to graph, but just to simply state the asymptotes. Okay, so the graph is already provided for you. In another lesson, we'll put everything together and graph it. Today, we're just going to analyze it. So if I just plot this really quickly over here, it's like a vertical asymptote, x is equal to -2, right? And then you have a horizontal at y is equal to 2. Okay. So the goal of this particular example is to use limit notation. And typically in Math 3, I don't teach students the limit notation, but here in pre-calculus, because this is on the AP exam, you're going to have to be familiar with it, okay? So, right, in plain English, right, let's start with the vertical asymptote of x is equal to -2. The definitions are written in your notes. So how would I describe the vertical asymptote other than saying, oh, x equals -2 is the VA? So I would write something like this, okay? So this is coming straight from your definition. So I would say, since what we're going to have to do is take a look at the limit. The limit as x approaches -2 from the left, okay? So you see that subscript negative? This means from the left, right, of f of x. So let's think about it. The limit as x approaches -2, meaning going this way from the left, right? Well, the y value, right, looks like this y value, which is right here, is going to positive infinity. And then likewise, I could say the limit as x approaches -2 from the right. Again, this little subscript, this little plus symbol just means from the right, of x. So if we analyze our graph, right, as we approach -2, okay, -2 is right here with this dashed line. As we approach -2 from the right, notice the y value, f of x, is going to -infinity, okay? So you could say, since, f of x going to positive infinity as x approaches -2, the limit as x approaches -2 from the right of f of x equals -infinity, then you can say, okay, therefore, x equals -2 by definition is a VA. Okay, so you can read that definition on your own, but this is how you would analyze this or describe it using limit notation of a vertical asymptote. Basically, f of x has to approach positive infinity as x approaches some number from the left, and limit as x approaches f of x has to equal -infinity as x approaches some number from the right. Okay, now what about the HA? HA clearly is y is equal to 2, right? But again, we have to use limit notation. So again, I would write something along these lines. I would say, since the limit as x approaches -infinity of f of x. So let's answer this question, right? As we're going to -infinity, which is this direction, x is going to -infinity, right? Notice the y value, right, is right here. It's getting close to 2. So the limit would just be simply, the limit as x approaches -infinity of x is simply equal to 2. And the limit as x approaches positive infinity of f of x, right, as I'm going this direction along the x-axis, right, notice the y value is also getting close to 2. Okay, so because the limit as x approaches -infinity and positive infinity approaches the same number, right, you could say, therefore, y is equal to 2 is an HA. And that's really just the idea of limit notation to describe asymptotes. The only reason why I'm covering this is because it's on your AP exam. Otherwise, I would just say, hey, just simply state y equals 2 is the HA, x equals -2 is the VA. But that would do you disservice if I don't mention this. So please watch the next couple of videos as I do the official examples.